Good morning, ladies and gentlemen. This is Professor David J. De Las Furias. What I will be discussing this morning, it's past 12 o'clock already. This will be an illustration on how to use a DC to DC converter. Okay, charging a 12-volt battery, this one here. This is the DC to DC converter. This DC to DC converter is actually for the meantime, I will be showing you this is actually buck boost converter, but for this illustration, I will be showing the boost mode, meaning if we apply a laser voltage by manipulating the rheostat, the one on the right, we could increase the output voltage of the DC to DC converter. Okay, this is the output. It goes to the battery. So whatever voltage on the output, that will be the charging voltage of the battery here. Okay, I would like to start it here. The input voltage to the DC to DC converter, the input voltage, actually emanates from this. I set it at 12.3. I want to show you. If I will try to toggle this first one here, the one on the LCD will be the voltage on the input. The voltage on the input is actually 12.27, okay, and the power output is 1.81 watts. Okay, this 12.27 is almost same as 12.3. There is a voltage drop on the wiring. The wiring is not perfect. So that's the voltage input to the converter. And to charge the battery, the output voltage, which actually emanates from this one, come out from this one. If you would like to see the voltage output, I will try to push this one. Okay, that's the voltage output. The voltage output with an input of 12.27, the voltage output is 15.54. So actually, we are increasing the voltage from 12.27. When it passes through the converter, it increases to 15.54. And the, what they call this, wattage consumption. Wattage meaning the consumption of the battery being charged. Okay, I will try to reset this one. Oh, that's 0, right? I will try to open it again. The voltage is 15.54, but still the current consumption, the wattage consumption, it's not the current because it's marked W, right? It's marked W. Should be the output power going to the, if we try to divide 1.78 divided by 15.54, we could determine the current. And the current, if the power output going to the battery is 1.78, the current is actually almost 115 milliamperes. So meaning to say this DC to DC converter is charging this battery here with a current of around 115 milliamperes. That's a small charge, but we call it the so-called trickle charge. But trickle charge is much more better than the bulk charge because in the long run, we are saving the life of the battery. Like on the cell phone, if we are always using the fast charging, the battery of our cell phone will not last long. That's why if there's the slow charging, we better use the slow charging. So that's the difference between fast charging and low charging. The battery life for the fast charging is actually lesser than for slow charging. Like what I said, okay, the output going to the battery is 1.75 and I divide it by 15.54, and the trickle charge is only 115 milliamperes, so 114.5 or 115 milliamperes. Okay, so this is one way on how to charge a battery by using a DC to DC converter. Why DC to DC converter? The power input is DC, okay, the power output is DC, that's why it's a DC to DC. Actually, we could operate this DC to DC converter without using this one. We can use a 9-volt battery on the input. Anyway, we could adjust the output by just manipulating this rheostat thing here. So whatever voltage on the primary, supposing it's 9 volts and we want to increase it to charge a 12-volt battery, the output voltage of the converter should be greater than 12 volts. So we could increase it by using this one. Okay. Like this one, if I will try to rotate this one, will it increase? No. It's constant at 15.54 volts now. The power input to the converter is 12.3. So that's the significance of this, what you call this, I think this is now a computer controlled. It got a software on the circuit. It got an IC that controls the voltage. Like what I said, the input voltage is 12.3, but it is maintained at 15.54. Okay? So I will repeat it. The term boost converter is that we applied a 12.3 volts, okay? What comes out is 15.54, so we boost, we increase. That's why the term 2 is actually boost DC to DC converter. Okay? The current output is not so much, but at least we are showing that it could charge a battery by using a trickle charge. Okay? So this is the concept of a boost DC to DC converter. We are applying a smaller voltage on the input to the converter. What comes out is a greater voltage on the output, this one. Okay, I will go back to the input. I'll toggle this one. Okay, 12.27 or 12.3. That's the input. Okay, with the subscript N over here. Yeah, N. So if I will try to toggle again this one, okay, that's the output voltage now, 15.54. The output is 1.69 watts. And as per computation, the current is around 115 milliamperes. Okay. The term 2 boost DC to DC converter, we are increasing the input voltage to a greater voltage on the output. We are boosting it. We are increasing it. Okay, that's why the name is actually boost DC to DC converter. Okay, good evening from Los Angeles. This is the concept of a boost converter. Okay, we are applying a laser voltage. What comes out on the output is actually a greater voltage. That's why we are boosting the voltage. That's the so-called boost DC to DC converter. Okay, good morning from Los Angeles. This is Professor David J. De Los Reyes.